Hello everyone. Today we will speak about a really important topic. Our subject is about analysis of the implemented project for the construction of a high-rise building between two low-rise buildings in the zone of maximum measurable influence of their foundations. So the construction of a high-rise buildings and the immediate vicinity of previously constructed buildings is always a difficult engineering task because the previously constructed buildings is in the zone of influence of the settlement of the new foundations on the deformation of the base and the structure of the existing one. The purpose of our research is to assess the effectiveness of engineering measures used in the construction of a high-rise building built in a zone of mutual influence with all buildings. For this, the authors solved the following tasks. Survey of a group of interesting buildings, analysis of engineering and geological data for the construction site, applied a modern method of computer modeling by the finite element method in the program Plaxis 3D. We propose to consider an interesting positive example taking into account all factors of mutual influence. A group 3 houses in the Russian Federation in Tambov City on the Savitskaya Street 156-158. The results of the technical survey of the group of 3 buildings built in the zone of mutual influence in the central part of Tambov are given. On the basis of the available engineering and geological data and the calculation of the stress-strain state of the piece using the Plaxis 3D program complex, the causes of wall deformations were established. An analysis of the implemented measures of the radius mutual influence during the design of the attached high-rise building of the third stage was made. These buildings are located in zones of mutual influence because their walls are tightly adjacent to each other. The first building was built in 1958 at Savitskaya 156. The second building was added after 5 years outside the zone of mutual influence because it is located 12 meters from the first. According to the residents, it began to deform immediately after construction, and characteristic subsidence cracks began to appear on the facades, especially the southern section of the house, bounded by the second expansion joint. In 1994, between two previously constructed buildings, construction began on the third one, designed by Tambov Garajan project, with a height of 7 floors. It was a challenging engineering task because the new house fell into the zones of mutual influence of the both buildings, which moreover had already damaged the load-bearing walls. To solve this problem, the following decisions were made. It was decided to strengthen the building of the first stage of construction from the side of the attached house with T-belts, to separate the levels of bearing mutually influencing soils of the foundations. The foundation of the new building is deeply laid below 10 meters deep, with a pale diameter of 800 mm. with broadening in the lower part up to 1200 mm in order to exclude dynamic impacts. Drilling bills with broadening are accepted. The strip foundations of the building of the second stage were built of concrete blocks (PS) laid on sand preparation with a thickness of 20 centimeters. Let's consider the imbalance of an extension of a new higher 7-story building to the existing 5-story one. In 2004 and 2018, the building of the first stage was recorded from the facades. At the time of the survey in 2005, according to the residents as well as a result of a visual inspection, the condition of the buildings was established. House number 158, new crack opening is not absurd. The facades have only old non-progressive cracks. The 7-story extension between houses number 158 and 156 is currently cracked and affected. Work is underway to strengthen the load-bearing structure. House number 156, there is the formation of new cracks and the opening of old ones. Destruction of the plated layer, sacking of the walls. Engineering and geological situation in the construction area. All buildings of the group under consideration have damage in the form of cracks on their facades. However, these damages are not related to mutual imbalance. So buildings of construction stage 1 and 2 have deformations associated with uneven subsidence. According to the schemes of engineering geological zoning of the territory of Tambov City, the group of buildings under consideration is located on the second above floodplain terrace of the Tisna River. 3D modeling of the stress state of the foundation building. System was carried out in the calculation program plus 3D. As a result of calculations, pictures of the distribution of displacement and stress fields in piece soil were obtained. The wet zone of soil subjected to vertical displacement 1636 mm is located along the perimeter of the building of the first stage of construction. Modeling in Plaxis 3D showed that its width is about 0.8 meter along the perimeter of the building of the first stage, 1.2 meter along the perimeter of the building of the second stage, and 0.5 meter of the third stage of construction. In the figure 6, the transfer of total vertical stresses from the foundation of the building of the third stage of construction to the lower, more durable, to second and third sandy soil. This reduces the vertical displacement under it. Accordingly, the imbalance from a higher building on neighboring these heavy ones has been reduced. Compressive vertical stresses, as it were, extended over the boundaries of the soil layers, almost not connected with each other. The pile foundation divided the zones of compressible soil beneath adjacent buildings to different depths, and he transferred the horizontal load from the highest 7-story buildings to a greater depth. So, and finally, we have to see the scheme of engineering geological zoning shows the effectiveness of the considered engineering solution in conditions of a high variability of the deformative characteristic of these soils. Sources showed the damage to buildings of the second and first stage was caused by uneven subsidence of the foundations, and buildings of the third stage were caused by a design error associated with the choice of an insufficient section of the columns. No deformations of the bearing walls caused by mutual influence were found. In general, this project can be considered very successful, and the engineering solution for the use of bored steel foundations in attached high-rise buildings is recommended to be used in such situations. Thanks for your attention, and see you inshallah in new video.